All right, let's jump right in. Picture this. You're standing at the entrance to a gauntlet. But this isn't about steel or stone. Nope. This one is forged from pure logic. Welcome to the high-stakes world of competitive math. The challenge? It's about to begin.
And the clock starts now. You've got exactly 40 minutes on the board, not 1 second more.
And in that time, you've got to solve 25 problems. Now, they'll ease you in, sure, but that difficulty curve, it ramps up, and it ramps up fast.
So what is this crazy challenge? It's the AMC 8 competition. And let me tell you, this is about so much more than just crunching numbers. We're talking a serious test of mental stamina, strategic thinking, and spotting patterns when you're under the gun. It forces you to think in a totally new way, to see the hidden logic behind it all.
So how on earth do you survive something like this? The secret? Well, it's not what you think. It's not about memorizing hundreds of formulas. No way. It's about having a blueprint, a master plan for taking these problems apart, piece by piece.
All right, let's decode this master blueprint, shall we? The whole idea is to completely reframe the math you probably remember from school. We're going to take those abstract, kind of boring concepts and see them for what they really are: incredibly powerful, real-world tools.
And this is where it gets really cool. Look at this transformation. Boring old ratios and proportions? That's the language of financial engineering. Quadratics? You know those parabolas? That's trajectory physics, the math that guides a rocket. Number theory? That's literally the backbone of modern cryptography. And 3D geometry? That's how we design and build skyscrapers. See, it's a total shift in perspective.
Okay, so remember this one from school? Direct variation. Y equals k times x. It's a pretty standard, maybe even kind of dry definition, right? It's technically correct, sure, but it doesn't exactly scream power or excitement, does it? But now let's look at it through the blueprint lens. Check out this question from a financial engineering context. Suddenly, that same simple idea is being used to make a high-stakes call about server capacity and trading latency. It's not a dry formula anymore. It's a critical business decision. That's the power of the blueprint.
All right, time to forge the first tool in our arsenal. Let's call this one the trajectory tool.
So what is this tool? At its core, it's all about quadratics. You know that perfect arc a basketball makes on its way to the hoop? Or the path a rocket takes as it soars into the sky? Yep, that's a parabola. And this tool is what lets us decode it. It turns what looks like a complex flight path into a simple, predictable equation.
Let's put this way of thinking to the test with a classic gotcha problem. You've probably heard this one. If a stock goes up 50% and then down 50%, is it back to its original price? Now, your gut, your intuition, is probably screaming, yeah, of course it is. But the blueprint, it teaches us that our intuition can sometimes lead us straight into a trap.
And here's why. Let's just walk through the numbers. Say you start with $100. It goes up 50%. Okay, you're at $150. Great. But here's the kicker. The 50% down isn't based on your original 100. It's based on the new total of 150. And half of 150 is 75, so you lose $75 and you end up with just $75. You're actually down 25%.
So what's the blueprint's secret weapon here? It's this incredibly simple, elegant rule: always multiply the multipliers. Just forget all those steps. A 50% gain? That's a multiplier of 1.50. A 50% loss? That's a multiplier of 0.50. You just multiply them together. 1.5 times 0.5 gives you 0.75. Boom! Your investment is worth 75% of what it started at. No traps, no confusion, just a clean, fast answer.
Okay, tool number 2, let's forge the perspective tool. This one is super cool because it's the hidden engine behind how cameras work, how optics bend light, even how 3D video games render entire worlds. And it all comes down to one single powerful concept from geometry.
And that concept is similarity. Sounds simple, right? It's the idea that two shapes can have the exact same angles and proportional sides. It's the reason a camera can take a picture of a massive mountain and shrink it down to a tiny photo that looks exactly right. It's all just about scaling things up or down.
But here's the crucial insight from the blueprint, the part that trips a lot of people up. Let's say you enlarge a photo so its sides are 3 times longer. Your scale factor, which we'll call K, is 3. Okay, simple enough. The perimeter, it also gets 3 times bigger. But the area, the amount of ink you need to print it, that doesn't triple. It increases by a factor of K squared. So 3 squared is times 9. It takes 9 times the ink. Knowing the difference between how length and area scale, that is a huge strategic advantage in these problems.
Okay, we forged our tools, we have the trajectory tool for our algebra and quadratics, we have the perspective tool for our geometry. Now, it's time to face a final boss, a real problem from the AMC-8.
And here it is. At first glance, this thing looks intimidating, right? Because it's mashing two completely different worlds together. You've got the abstract algebra of polynomials and the simple geometry of a rectangle. This is what you'd call a classic Tier 3 problem, designed to make you sweat.
But we have the blueprint, so we don't panic. We have a strategy. Step 1, identify the domains. Okay, we see algebra and geometry. Step 2, activate the right tool. The area is a quadratic expression, so that's a job for our trajectory tool, which is really all about factoring. We need to reverse engineer this. We're looking for two numbers that multiply to 10 and add up to 7, and that's got to be 2 and 5. So the sides of our rectangle have to be x plus 2 and x plus 5. Once you have that, finding the perimeter is just simple arithmetic.
And that right there is the whole point. The blueprint isn't just about grinding your way to an answer. It's about seeing the problem's hidden structure and then systematically dismantling it with the perfect tool for each part. It's about being efficient and, dare I say, elegant, especially when the clock is ticking.
You know, when you really think about it, this whole journey through the gauntlet teaches us something pretty powerful. It's not about how many formulas you can cram into your brain. It's about the versatile, creative toolkit you build. Each one of these tools gives you a new lens to see the world, whether you're looking at financial markets or the laws of physics.
So we've seen how this blueprint can decode the path of a rocket and how it can cut through the noise of financial markets. It leaves you with a pretty big question, though, doesn't it? If you start seeing the world through this kind of toolkit, what else could you unlock?